Okay, let's take a look at another example of addition. And this time, let's try to add in base 5. So we're going to add 234 base 5 to 342 base 5. Now, this time we'll do the addition with the place value chart, but this time instead of using the concrete number representations, we'll actually use the symbols for the numerical amounts. Also, for convenience, we'll also use the symbols 5, 6, 7, 8, and 9, and as a note, these symbols do not exist in our base. Base 5 only has the number symbols 0, 1, 2, 3, 4. 5, 6, 7, 8, 9 as symbols do not exist, so our final answer cannot use these symbols. So we'll set down our empty place value chart, and we don't really need to do it, but we've been doing it in all the other problems, so let's go ahead and indicate the size of each of our units. So we have our first set of units, those are going to be the ones, which we'll write as 1. Our set of 5, again, that's our base, 5 ones, and we'll write that as a 5. And then our next set is going to be 5 fives, and we'll write that as 25. And 5 25s, and we'll write that as a 125. And these are going to be the units in base 5. Again, we don't really need to know what these are. They're not going to be important for the operation in base 5, but it's convenient to have them to refer to later. So next we're going to want to set down our add-ins. Now, it is convenient if we write them from smallest place up to highest place. So for our first add-in, we'll write 4, then 3, then 2, working from lowest to highest place value. And then for our second add-in, we'll write 2, then 4, then 3, again working from lowest to highest place value. All right, so our next step, we're going to, so to speak, add normally, but this time we're going to make sure that we stay entirely within the column. Also remember that for convenience, we're going to use number symbols of 5, 6, 7, 8, and so on, even though those do not actually exist in our base 5. So let's go ahead and add those 2 and 3 together, make an amount that we would call 5, and we can write this way. 3 and 4 make an amount that we would call 7, and we can use the 7 symbol. And then 4 and 2 make an amount that we would call 6, and we'll use the 6 symbol for that. Now remember that the symbols 5, 7, 6 don't actually exist in our base. So in order to get our final answer, we need to bundle and trade. So let's see, in base 5, again we're working base 5, so we want to find a bundle of 5 and trade it for 1 more in the next place over. So let's start with our lowest order of magnitude, that's 6, and 6 is a bundle of 5 with 1 more, so I'll bundle. There's my bundle of 5, there's my leftover, and now I can trade this bundle of 5 will get me 1 more in the next place. And one last step here, I want to combine the 7 and the 1 together to make a set of 8. And again, I can do the same thing. I have a set of 8, but I want to make a bundle, and 8 is a bundle of 5 and 3 more. So I'll break that apart into a bundle of 5 and a bundle of 3, and I'm going to trade this 5 for 1 more in the next place over, and then I'll combine the 5 and 1 here to make a 6. And again, one last step, this 6 here is a bundle of 5 and 1, so I can bundle 5, 1 left over, and then trade this 5 for 1 more in the next place over. All right, one last check. I look at the amounts that I have in each of these places, and I can't find any more bundles of 5. So there's no further simplification that's possible, and so now I can just read off the answer to our sum digit by digit. It's going to be 1, 1, 3, 1, and we do want to remind the reader that we're actually working in base 5, so we'll write that as a subscript.